All right, so sine is positive in those two quadrants. Now, it tells you that tangent is negative. Where is tangent negative?
2 and 4.
2 and 4. So now, okay, now that means all my answers are going to be in quadrant 2. Okay, now, I have sine. I need to find cotangent and secant. Gee, if only there was an identity that related sine to either cotangent or secant.
I know one. On the spot.
Is there?
Yeah.
What is, okay, I say your name first.
Well, since sine over, okay, wait, so since a sine of theta over cosine of theta equals tangent of theta, then cosine of theta over sine of theta is going to equal.
Right, so we need to find cosine, right? Okay, so look at this. We need secant, which is like cosine. Once you have cosine, you can also find cotangent because it's cosine and sine divided by one another. So, since I have sine, why don't I use that first Pythagorean identity, right? And I can do sine squared plus cosine squared equals 1. And then cosine will give me secant, and from there I can find cotangent. So, sine squared theta plus cosine squared theta is equal to 1. Sine squared theta is 1 over 3 squared. There are no calculators allowed on this quiz, by the way. Okay? 1 over 3 squared plus cosine squared theta is equal to 1. So that means 1 over 9 plus cosine squared theta is equal to 1. Subtract 1 over 9. Cosine squared theta is 8 over 9. Take a square root. Cosine of theta is plus or minus the square root of 8 over the square root of 9, which is plus or minus 2 root 2 over 3. Now, because we are in quadrant 2, cosine is negative there. So this is going to be negative 2 root 2 over 3. Is that even what we want, though? No. We want secant of theta. We can just take the reciprocal. That's negative 3 root 2. Negative 3 over 2 root 2. You don't have to rationalize it. If you do, it'll be 3 root 2 over 4, but you don't have to rationalize it. Benny. Yeah. So I do want you to stay in theta, because this is where we're going to train ourselves to do it. It could even be alpha, guys. Like, it could be any old letter, okay? Any old Greek letter. Okay, question? Okay. Now, okay, I found secant. Now I need cotangent.
So now you can use
cosine over sine. Cotangent is cosine over sine of theta. So cotangent is cosine negative 2 root 2 over 3 over sine 1 over 3. If this gets you anxious and nervous, write it like this. Negative, so the first fraction divided by 1 over 3 is times 3 over 1. So now I get negative 2 root 2. So cotangent of theta is negative 2 root 2. Right? And cotangent would have been negative there, right? So we're good. Okay? Now, Okay, our least favorite word for the time being, simplify. Oh my gosh, what does that mean? Okay, so what am I going to do here? I don't know what I'm going to do here. Okay, lots of things you could do here. One is change everything into sines and cosines and see what cancels. Okay, so another thing, okay, so if this was one fraction plus or minus another fraction, what would you do? Common denominator. If this was not a fraction, but one, like long expressions, what would you do? What would you try to do? Factor something out, okay? What do you have now? You now have a fraction. How many terms are on top? One or more than one? More than one. How many on the bottom? One. So look at what you can do. So if you have, let's say, 3 plus 5x over x, can you split this up and do 3 over x plus 5x over x? Yeah. Let's do that here and see what happens. So secant x cosecant x over secant x cosecant x, oh my, that looks pretty cool, minus tangent x over secant x cosecant x. Okay? This is 1 minus, okay, what do you propose we do here? What do you think? Change to what? Sines and cosines. Okay, so let's do that. Tangent is sine over cosine x. Secant is 1 over cosine x. Cosecant is 1 over sine x. Okay? This is all very confusing. So here's what I'm going to do. I'm going to rewrite this. 1 minus. Now look, it's the top fraction divided by the bottom, but dividing by a fraction is the same as multiplying by the what? The reciprocal. Times cosine sine over 1. Yeah.
So can you say dividing by cosine is multiplied by sine?
Absolutely. Yes. Okay, so cosine cancels with cosine. Oh my God, you see it, don't you? So now what do I have? 1 minus sine x times sine x. This is 1 minus sine squared x. What does that remind you of? Cosine squared x. Right? Because that's a Pythagorean identity. Okay, so how do we know to do that? I've told you, whenever you have a trig function squared, like cosine squared, sine squared, secant squared, and then it's plus or minus a 1 around it, look for an identity. So look at this identity, right? Sine squared plus cosine squared equals 1. And then 1 minus sine squared is cosine squared. So it's a good idea if, like, as soon as you get your quiz, maybe up at the top corner, write those 3 identities, right? Because the sine over cosine equals tangent, that you know. You know, the secant is 1 over cosine, that you know. But write the 3 Pythagorean identities, and then you can always refer back to it. Yeah.
So if we like get an answer 1 minus sine squared x, we always have to like make it equal to that. We get like partial credit.
Yes.
So what's stopping you from like canceling the secants and cosecants out and just having the unit term of that? Like,
Where?
In the last one, like, why can't you just cross them out?
Oh, from here?
Yeah.
You can't because, okay, so if you have 3 plus 5x over x, can you cancel out the x's? You can't because it's the 5x added to something else. You can only cancel stuff out from top and bottom if like the identical thing on the top appears on the bottom, right? It's secant x cosecant x minus tangent. Because of that minus tangent, you can't cancel out the secant.
Okay.
Okay?
Because it also applies to the negative tangent.
Yeah, exactly. It belongs to both. Okay, what would you propose here? Common denominator. So common denominator here will be secant x plus 1, secant x minus 1. And so now I would just like multiply each fraction top and bottom by the other denominator, right? So this is secant minus 1 plus secant plus 1. Okay, the negative 1 and the positive 1 go away. Now I have 2 secant of x over what? But when you multiply, it's secant squared x minus 1. What is secant squared x minus 1? Not cosine.
It's cosecant squared x.
It's tangent squared x.
Wait.
It's tangent squared x because do you guys remember the identity? Okay, so look at the identity. Secant squared x minus 1 is tangent squared x. So again, the first thing you should just write those down. So this is tangent squared x over 2 secant x. And now that so secant is 1 over cosine. So this is 2 over cosine x. This is sine squared x over cosine squared x. So 2 over cosine x times cosine squared over sine squared. How many cosines cancel? Oh, it's 11:30. 1